Hi, Jeff. Is it good you present first?
Oh, I can present first, absolutely.
Yeah. Okay. Okay. Good morning. Since last time, we have been discussing text mining. And Jeff, the presentation is on the text mining session. We just ran out of time. So we will start with his presentation on text mining. Then we will go to the session on the new topic, which is a choose finding. Okay. Let me see. I think this is the right one. Okay. No, not this one.
You had it up before.
I just had it before. You can take it first.
All right, let me. Does this work okay? All right, I'll try to put a little this up here. All right. Just let me know if. Oh, that sounds very nice. You absolutely had it before. Where did it go?
Let's do it one more time. Okay.
All right. Oh, there it is.
I know, but I tried to save it.
Oh, okay.
Save it one more time.
And it opens like that. I can present off of that.
Try to see. Let's save it one more time. I just try to make sure it is in the right place.
I think I can make it go. We can make it go to full screen, so it'll be okay. And yeah, oh sure. And then we can go like this, and then do we have a keyboard? If we, there we go.
Okay.
That should work.
Okay.
Thank you. All right, I will try to be brief, but yeah. So what I'm going to be talking about today is opinion mining and sentiment analysis, and they're two very related yet slightly different things. I'll be going over that difference in a little bit. What I looked at for this presentation was a very large survey paper from 2008. So there's some ideas that have likely come out since then, very likely related to the ideas that we're discussing in this class, and I'm going to go over that as well. But I want to show sort of the main concepts of opinion mining so that perhaps you can use these concepts in your own research and your own projects. So here's the main idea. Why do people want to do opinion mining and sentiment analysis? People care what other people think. And that simple idea is exactly why people do this. So Amazon is a perfect example of this. You have reviews, and people tend to buy highly reviewed products. But more than that, when people look at the reviews, and it's kind of hard to see this here, but you can see 168 people found this review to be helpful. And those are the sort of reviews that people tend to like. So companies are concerned with opinions and determining how to market their products, how to sell their products, and how to make their future products. And customers are also concerned with opinions so that they know which products to buy. So furthermore, this was a funny little thing that was in the paper. Opinion mining can be used sort of politically to take a look at the relationships between different major political figures. So this is something that the New York Times did manually with no automated systems after Hurricane Katrina and the response and whose fault it was. So I thought that that was kind of interesting, so I went ahead and put that up there. But here's another great example for visualizing. So this is what people tended to like and dislike on the Volkswagen Golf. So the whole idea here is to take these free text reviews, not necessarily these long forms which can be expensive to create, these free text reviews and determine what do people like or dislike from these reviews. So just to sort of review, some of the things that we have seen in this course so far is we've seen phrase mining and topic mining with, well, I'm not going to repeat what we've already seen too much, as well as entity typing. So the idea here is that opinion mining can generally be seen as sort of the more basic formation of entity typing of linking phrases and clustering them with two major types, positive and negative. So that's it, right? We did it. We found out how to do it. No, we didn't. So opinion mining is much more difficult than things may seem on the surface. So words and phrases are, I could just read off this list, but so who here understands sarcasm perfectly? Raise your hand. I see nobody's raising their hands. This is great. This proves the point. Even people have a hard time determining what is the sentiment of documents. So machines certainly are going to have a very hard time. And so one of the great examples from the paper, this is just straight from the paper, the film should be brilliant. It sounds like a great plot. The actors are first grade, supporting cast is good, and Stallone is attempting to deliver a good performance. However, it can't hold up. Now, we know that that is a negative review. But look at all this. Brilliant, great, first grade. All of these words suggest that this is an incredibly positive review. So there's a lot of subtlety that goes into this. And yeah, so I thought that this was sort of a funny little picture. Unless, of course, Mr. Important is running late, you can follow the speed limit. So a couple of challenges that were addressed by the paper to be conquered. Things like rating inference, so determining how positive or how negative a review is. Determining agreement detection, so determining whether two reviews have the same opinion, not necessarily positive or negative, but the same opinion. Determining if the review even has an opinion, and that's a bigger challenge than you would think, because there's a difference between opinion versus fact. And then the idea of using joint topic sentiment analysis, the idea is that different topics as a whole have views towards each other, and the easiest way is to talk about this is politically with, say Republicans have a bad view towards Democrats and vice versa. For rating inference and trying to determine how positive or negative things can be, there's the idea you have term presence and frequency. So really low frequency linking phrases can really suggest a lot of emphasis, which is why frequency can be good. Phrases, as we all know, can be very good for helping this out. There's also been efforts to use natural language processing to try to extract the parts of speech out. And negation terms can be very important. Like I like this book versus I don't like this book. The negation term seems to flip the opinion here. And it's also very important, as you see with these two examples, to not just look at the linking phrases on their own, but also to take a look at the sentence as a whole and the context that the linking phrase appears in, because that can be incredibly important in determining sentiment. So I'm going to go ahead and hurry up because I am running out of time. But so rating inference, the idea here is that it's just pretty much what clttype does. So you try to use these linking phrases to detect relationships between different entities. And the idea is that these phrases get classified over time. You can use things like thesaurus and that sort of thing to try to do a propagation from a small, limited data set, as well as using conjunctions to try to do this propagation. For example, if something is elegant but overpriced, you get the sense that elegant and overpriced have opposite connotations. But usually this is a machine learning task and requires some labeling. Objective versus subjective classification. Generally, the idea here is that subjective text tends to cluster around subjective text, and objective text likely clusters around objective text. So in general, if you have some labeling of subjective versus objective, then you can propagate that about using similar verb phrases being used. Oh, and this is just a quick little comic about opinion versus fact, and it can be hard to tell what people think is an opinion, but anyways. And just like I talked about with joint topic sentimentality analysis, so this was a very small section in the whole paper, but the idea is that you use different topics to help determine better heuristics. So that if it's, the United States is an ally of Japan, and you get the sense that the United States and Japan are allies, and if Japan is the ally of, say, South Korea, you might get the sense that the United States might also be an ally of South Korea. So in general, this is largely done as a machine learning exercise, but we can definitely expand it. This could definitely be improved with quality phrase mining and topic mining. And 3 strategies I went ahead and outlined for potential for use. A priori, trying to assign sentimentality to paragraphs or sentences for linking phrases, or trying to simultaneously assign sentimentality as you're mining out entity links with sentimentality associated with them with some sort of optimization framework. Or after the fact, you have your links and your linking phrases, and you try to assign sentimentality after the fact. So those are 3 sort of main strategies that I could see going forward with this. So there are no more slides for this. So with that, does anyone have any questions?
Okay. Thank you very much. Thank you. That's great. Thank you. Okay. Thanks to Jeff for the nice talk on the opinion mining. And we just ran out of time. We will not have much time to cover this important topic, but topic is very good, especially after we learn the new technique on text mining. Okay, we know how to mine phrases, types. Obviously, we can get into this fertile field. You may generate some really good papers. And for phrase mining, even in our campus, in our department, 1.5 years ago, Professor Zhai graduated 1 PhD, Hongning Wang. He now is a professor in University of Virginia, UVA. And his whole thesis, the 5 years work, is on opinion mining. And, so you can read his thesis, got many research papers published right on this topic. You can see how important the topic is, right? Okay, so let's move on to the, let me see how I can get it out. Let me see how you may try to see. Okay, thank you. Yes, okay. Now let's come down to a new section, okay. This one actually is really between opinion mining, text mining, and the new topic is truth discovery, okay. So we will try to spend a little over 1 lecture to finish this truth discovery, but it's very important. Truth discovery, also called veracity analysis. Veracity analysis is somehow trying to see how you conform to the truth. Okay. This one is still in Brazil. It's this one, if anybody knows, this one is in the Rio de Janeiro. I think last time, if you watch the World Cup, 2014 World Cup, I think 14 World Cup is in this city. And this year's Summer Olympics is also in the city. You probably will see the scenery quite often. Actually, you can if you watch carefully, there are some lines going up to this part, and this part has another line going up. Actually, lots of tourists going up right on the very top of this sugar loaf mountain. Okay. So let's first discuss why we want to do choose finding. What is choose finding? Okay. Actually, this is a very popular, very important problem. Is now you got lots of information. You got information flooding, or overloaded. But not all the information are true, right? You actually, quite often you see there, sometimes you get rumors, you get something unbelievable, but later it may turn out to be the false one. Okay, that means you got lots of information. There are lots of information providers, but not every piece of information is the truth. Okay, the problem is, of course, you can say I can get a training, somebody label it. Say this one is true, this one is not true. You think about it, who will have time, who will have energy to label all the pieces of information? Right? There is no absolute judge to say this piece is true, this piece is false. Then the problem becomes you get lots of information. Can you have an automated mechanism? That means you invent some algorithm which may help you to check lots of information, judge which piece is true. Okay, so that looks like a dream. Okay, actually that's exactly one of my PhD students. Actually, I met him last Friday, when I gave a talk in Google. They finally, he was in Microsoft research and also was in Google, and he actually joined another company, but he did have dinner with me on Friday. And Xiao Xinying, he got a 2008, the very first ACM KDD dissertation award. That's the very first one he got it. But one of the famous one, actually, everybody knows him because he invented an algorithm called Truth Finder, okay, the finding truth. So that simply says he developed an automated algorithm among many, many conflicted pieces of information without anybody trained. He found which piece is true. Okay, that sounds science fiction, right? So actually, he first came back from a summer intern. I remember clearly. He went back to my office. He said he went to a very big company. The company actually gave him a task on summer intern. Said on the web there are so many pieces of information. Can you develop an algorithm to judge which piece is true? Okay, he came back. He said, I actually told the boss, said, it's impossible for me to solve this problem. Nobody in the world can solve it. So he chose either task. It's still a very good task, and he finished. But he did, bring this one back, said that looks like impossible. But later we got some discussion, and he worked out the first algorithm called Truth Finder. And let's see how he did it and why he got this award. Okay, so that's actually his slides. The first work he published in the KDD 2007 and later turned to a journal paper published in 2008. It happens this paper is one of the most cited papers on truth discovery because it's the first piece of work. Okay, that's actually his slides. If you look at the problem, he actually did some study on the opinions. You say, what is the truth? Okay. Actually, he found most people, you can say 54, you still cannot say most, but at least over half of the internet users trust the news website, like CNN, like New York Times. They trust this news website because they think most of the things they reported are true. Okay. But 26% of websites only trust the product website. That simply says the product, when they put it down, and people may think it may contain some hidden information, not everything is true. Okay. But if you read blogs, you really can see the blogs, people trust the information on the blogs. The personal blogs is only 12%. Simply said they really may not trust it's true. Okay. So the problem becomes if you get multiple conflicting results. That means when you see a piece, some people say it's A, the other people say it's B. A and B are conflicting. Okay. Then whether there's any way you can automatically identify which piece of information is right, is truth. Okay. And that one, we work out a term called veracity analysis. Veracity means conformity to truth. Actually, once you see the recent appearance on the big data, they say there are 3 V's or 5 V's, and one V is volume, okay? Another one is velocity, and the third one is veracity. Veracity means the information, whether it's true or not, is very important, okay? The trustworthiness of the information. Okay. Then he worked out a very interesting problem with this. He came back from summer intern, and he said the boss gave him a very tough problem at the beginning. And he brought back, he said, I really want to solve it. I thought of many days, I just cannot get a clue. Okay. Then I discussed with him, I said, we better find something in the real world we can judge whether we can make assumptions or something. Then later, about a week later, he came back. He said, I found something quite interesting. I said, what did you find? Actually, the person, the company gave him this task was Amazon.com in Seattle. Okay. He came back. He said, Amazon has a website. You get lots of books. The book has the authors. Then he says, I actually look at many, many other websites. They all sell books. Like Barnes Noble, Powers Book, A1 Books, there are many. Okay. Of course, that's in 2006 to 2007. Now many companies on the web already collapsed, I believe. You probably cannot find that many now. Okay. But he looked at this. He said there's a very interesting thing he found. I said, what did you find? He said, everybody would trust. If you give me a book, the book author must be unique. Okay. It must be exactly the same. But he found actually get the same book. He just to pick up one book called Rapid Contextual Design. Of course, it's not a very popular book. And there were 3 authors, but he found that the different things, different companies put on the website, they all have different author set. If you look at this, they're all different. Okay. So the same book must be only one is true. And he actually went down to the website, downloaded Amazon.com, the real page. He watched the page, what they write. He found there's only one truth. A1 books wrote down like this. This actually is exactly what's shown on the cover. Okay. Of course, you may say Barnes Noble is not too bad, because if you look at Barnes Noble, the only thing they miss is the second author, the middle name. Okay. Otherwise, it's also right. But you look at the Powers book. Powers book only got one author. You look at the Conward books, they got 3 authors. That looks really, really bizarre, because this is really like some Spanish name. They put they put a father and mother's name getting together, become their last name, right? It looks very strange. Okay, so there must be some way you can judge. Okay, that means without an absolute judge, because nobody can give you a label for every piece of book. There are millions of them. Okay, but if you get all these different websites, can you judge without anybody trying to judge which piece is right? Okay. Then he worked out a graph. Okay. And that you can say is a heterogeneous network, but it's used in a different way. Okay. The graph is, looking like this. Okay. You have website, or you can say information providers, like Barnes Noble, Amazon, all these things. You get facts, and you get objects. Okay. The facts actually is claimed facts. It simply says the website W1, say the book O1, the author said it's F1. But W2 said it's F2. Okay. That means they have conflicting, at least inconsistent claims. Okay. The problem is if you have just two objects, you have 5 different claims. Okay. Definitely for each object, likely only one will be the right one. The problem is if you watch this graph for several minutes, can you figure out which piece is right? I bet if you just watch it, if you're smart enough, you may be able to figure out. Okay. Let's turn the graph a little. I just show the graph a little. I see whether you can figure out before I give you a solution. That's the key graph. He wrote something. He finally said, I got the algorithm. Okay. This bar is a hint. Okay. Can you, based on this hint, you work out your algorithm, the right algorithm by yourself? Okay. If you can work it out, it simply says you really have the capability to reinventing this algorithm, right? So can you work it out? Anybody can just watch this, can see you can work out the algorithm. Give you 30 seconds. Anybody can work out? I mean, just watch this graph with a hint of the bar, the length of the bar. The length of the bar actually is the truth, okay? The trustability. Yes? Yes. Brilliant. You got it. Okay. Simply say within 30 seconds, you reinvent what Xiaoxin's algorithm. Okay. That's exactly what he did. Okay. He said he watched this bar. F3 got the 3 people vote for F3. Okay. F4, so only 1 person vote. Okay. You think about this. Of course, something, anybody can go wrong. But if you got one thing, 3 people vote, say this is the author, okay? 1 person say no, this is the other one's author, okay? Likely, you just think about this. Likely, this F3 should be the right one. Okay, you think about it. If you make a mistake, if people make mistakes, they make of all different kinds, okay? That's a very important principle he worked out. And just give you a simple example, okay? Of course, if you intentionally try to hide something, it's different. You just think about it. Suppose a policeman capture a group of robbers, okay, or thieves. Suppose a policeman captures 3 thieves who just stole a bank, okay? So how do you think the police will do investigation? You say, police will say, oh, let's get together, get a panel discussion, see what happened. That will never happen, right? The police will not be so stupid. What the police are doing is you will isolate every thief, isolated each one, and you question the thief in a substantial way. Okay? But police did not have the truth. How police will find the truth? Because if people are lying, they lie in many, many different ways. The 3 thieves, once you isolate them, it's very hard for them to lie in a consistent way, right? When you start questioning them in depth, they will lie in a very, very strange way. They will never collide, okay? But once you question these three thieves, you find they say something consistent. That likely could be something really happening, right? So that's a common sense for police. It's common sense for everyone. That's exactly the way. If you see the three people say something consistent, likely this one could be the truth, okay? If they all lie, they lie in so many different ways. How could they get it? F3 is the right, okay? So you get this, then you actually have some score. That's exactly the analysis. You say, because now you see F3 was provided by W1, W3, W4, and F4 was only provided W2. So you will trust W1 a little more than W2, right? Since you trust W1 more, now W1 said this book should be F1. The W2 said this book should be F2. Which one you trust? You don't want to trust liars, right? So if this guy make mistake, actually in many cases, even when we do the grading, I actually told the TAs, so if you read people's grading at the very beginning, I'm not very sure. You look at if they are a brilliant student, give you the answer, there's another student give you an answer, they get different answer, likely trust this A+ student a little more than the people only get a C on average. Right? That's actually is kind of thing we know in the common sense. If W1 keeps giving you good answers, you trust W1 more. Now they are different. Which one you trust? You trust W1 more. Then likely F1 bar should be longer. Okay, that's exactly the final decision. You will watch this. You will see that the F1 likely will be longer than F2. Okay, of course. You may say, that's only one or two pieces. That's exactly, you think about this. There are hundreds, at least we say dozens of information providers on the website who publish the books. But there are millions of facts. The trustability with these millions of facts, you can make a very trustable judgment. That's why he built this. He went back to this website. He almost can, for every piece, he almost can say which piece, which information is right. Okay, nobody trained. He corrected many, many mistakes on the web. Okay, that's the one, that's a simple, you can say simple algorithm, but you watch it, if you really, within 30 seconds you got it, that simply says, you have the capability to reinvent this truth finder. Okay, so let's go back. I think this is a brilliant test. Let's go back to his whole reasoning. Okay. The reasoning, the first thing says, that usually there is only one true factor for property of an object. I actually went down to Google. The Google people on Friday, they told me they got a brilliant new paper just accepted by WWW 2016. That's like we just learned, Jialu's algorithm, he just published also in the same conference, just accepted. The real publication is next month, okay? And they actually also on the web, they try to judge, for example, if you say the population of USA is what, they actually, with a huge amount of text, they try to get hundreds of property of a single entity. They try to automatically adjust it. For example, the population of a country. Okay? And a country has many, many other properties. They want to go to the web to extract hundreds of attributes or properties for any single entity automatically. That's what they done in Google. Okay, that's several Google researchers just published a paper, including the person you just read the paper, Xiao Yu. He did a recommendation. He was a host. He actually was also the co-author of the paper. Okay. But the first thing is you assume a property is only one true fact, and you can justify the true fact. Okay. This is different from the opinion. The opinion may have different opinions. That's exactly, Jeff just gave a one. You can say this is Republican, there's a Democrats, they have different opinions. That one we cannot make a judgment. Okay, this one cannot say which one is true. Okay, because you really have different opinions. Okay, but we assume there's only one true fact. There's only one thing true. You can make a judgment. Okay. Then the true fact appears to be the same or similar on different websites. Simply says, suppose even they have slight difference, maybe they are still consistent. For example, we just had Professor Jennifer Widom visit us a month ago. Jennifer Widom, J. Widom, actually, people may write it differently, but these two, you can think they are different, but they are consistent. Okay, that means you still think it is the same truth. And the third one is the fourth fact on different websites are less likely to be the same or similar. That heuristic, you probably were by it. That's exactly, I said, this police, right? Questioning the thieves. The thieves, once they start fabricating something, they're unlikely to be the same or similar, okay? Then the first one is a website that provides most true facts, or for many objects, will likely provide true facts for other objects. That means if I got an A+ student, I trusted this A+ student to work more than the trusted like a C- student. So that simply says you build some kind of trustability for the information provider. Okay. So based on these four principles, he worked out the algorithm. Okay. His algorithm is a little like hits. You probably say the hits, we have the websites, we have, like the hub and the information, the web and the hub. Actually, it's the web page and the hub page, they are actually mutually enhance each other. Now, he says, now we have two things. One thing is the confidence or truth of the fact. The other one is the trustworthiness of the websites or information providers. These two things can mutually enhance each other. In the sense, if the fact's likely to be true, it will be credited by many good information providers. Okay? And if the information provider provided many, many true things, the information provider's trustworthiness will increase, will enhance. So these two things, on the trustworthiness, these two things are mutually enhancing each other, right? So then you probably can see his algorithm is somewhat like hits. Okay. He actually uses information providing back and forth to mutually enhance each other in a networked way. Then he developed this algorithm. That means at the very beginning, he assumed, I do not know anything. Okay, everybody is equal. But then he started doing, this mutual enhancement, okay, using his four principles, okay. And that means initially each website, or you think each information provider is equally trustworthy. That means I do not have, precondition who is true, okay. And actually, he did not have condition like a Barnes Noble. Even in Google, is ranked #1. He did not say Barnes Noble is always true. Okay. Actually, he later found lots of mistakes in Barnes Noble. Okay. And based on the four heuristics, he can infer fact confidence from the website, and then backwards and repeating until it's stable. That's why if you look at his formula, basically saying he was thinking the website or information provider like a hub. You provide information for many, many facts. Okay. Then you get it's more like hub and authority. They mutually enhance each other. The difference from the hub is hub and authority is finally you give the rank of the hub, or the rank of the information, the web page. Now, he says it's not a ranking, it's on the trustworthiness or confidence. Right? So that means the formula will be different. He cannot use a formula like his. He actually used formula of his own. Okay. It's quite interesting because he gave this paper. and he referred to Hub quite, the hits quite a lot. Then the reviewer, there are different opinions of the reviewer in KDD. They review his paper. Some people say it's very novel. I really, really love this paper. The other guy said, this is just a replay of the hits algorithm. I don't think it's so novel. So then finally the paper, get into, they call the shorter paper. It's not a full paper. But actually it's very interesting. After the paper got published, everybody loves it. So then he actually said, I only get the paper published in 5 pages instead of 9 pages. I have to send it to journal. He sent the full paper to the journal. The journal immediately took it. That's why you see the KDD 2007 is a shorter paper, and the full paper actually is in the IEEE transaction on knowledge and data engineering. Okay. Then both papers actually got a very high citation. So that's the one I just mentioned. That's exactly, look at the bar, you will see the trick of the bar, right? His formula actually is pretty simple if you think about it. The formula is different from the hits algorithm, obviously, because you're looking the confidence, the trustworthiness of the website, that's a T. Then the confidence of the fact is this S is a summation of the fact confidence. Okay, so he basically said these two formulas are mutually enhancing each other. In the sense, you can see this is the fact. For each fact, okay, you get some confidence. You add them together, divide by the number of total facts. That means you suppose you get 1,000 books. You can add them in. You finally divide by 1,000, right? That's the trustworthiness of this website. That means suppose Barnes & Noble provided 1,000 books, of course more than that. Then you look at each fact, your justified confidence. Then you divide by all the 1,000 books. Say how confident or how trustworthiness of this Barnes & Noble. Okay, so that's the idea. Then how do you get for each fact, how do you get the confidence? The confidence actually is based on trustworthiness, and 1 minus this trustworthiness. You multiply this with all these different websites, and use 1 minus this. You actually get the confidence. Okay. He basically used these two formulas and put them in a loop, and back and forth, you actually can derive all the final thing. Then I better give you the real test result he tried. And actually, even his data sets become a very standard. Many people following, try to beat this algorithm, use exactly the same data set. He actually downloaded, manually checked. Okay. What he got is, he got over 1,000 books listed on this book site. And every time he pick up 100 books and to do this analysis. But the interesting thing is he has a real judge. The real judge is book image. That means he went down to Amazon. He downloaded the book image. Of course, something cannot see. He even went down to the real bookstore to check it. Right? He downloaded this book image to check what are the real authors. Okay. Then he actually becomes a very interesting one. Is he competes with many algorithms, but he finally competed with many other websites. His choose finder with many other websites, and here he only lists Barnes & Noble. Why? Because in Google, you look at the online bookstore, Barnes & Noble was ranked #1. And he said, if I can beat #1, that implies I can beat everyone, right? So he just showed he can beat #1. And how he can beat #1, you can see this, is he look at the book, the correct one, choose finder finding which is the real author set, 85 correct, within this 100 books, he found 85 correct. Barnes & Noble only got 64. That means Barnes Noble did make some mistakes. He counts anything and make mistake. For example, even you miss the middle name, it's a mistake. You count everything you make mistake is a mistake. Then ChooseFinder got 85, Barnes Noble got 64. Then you look at the missing authors. ChooseFinder only missed 2, Barnes Noble missed 4. You probably see all these incomplete names. They simply say you missed the middle name. Wrong or first middle names, or it has redundant names, or add incorrect names, or no information. Whatever you can see is his method is better than Barnes Noble. Okay, so that's a little surprising, but actually he says nothing surprising because he actually is using hundreds of bookstores, right, to get a collective information, including Barnes Noble, right? Then he found another interesting one is which book site is more trustworthy. And he found, actually it's very strange, he found like this one called Mildred Books is most trustworthy. Every piece of information he provided actually is right. And there are other bookstores, you never know it, they provide a very high accuracy. Okay. But the problem actually is they do not provide that many books because he put 100 books as a standard. They only provide, among these 100, they only provide, like this one, only provide 10. They don't sell many books, but they do a good job on data input, right? But Barnes Noble actually sell lots of books. Among these 100 books, he found 97. Simply says Barnes Noble is really, really, collected most of the books. But the accuracy is only 0.865. But Powers' book, which at least at that time it was another one, like a Google rank number 3, that simply says it's a pretty big one, and only provided 62 books, 42 books, but the accuracy is pretty low. Probably can see. So that simply says he really using his simple algorithm, very short algorithm, beat everybody. Okay, so you can see that's a one is pretty amazing, and that's a one actually got lots of people following up. I met last Friday. I met Luna Dong. She was also a very famous researcher on choose finding, and she currently is working in Google, previously in Google Research. Actually, for her most recent paper, I think a KDD 2014 paper called Knowledge Vault, representing Google, published, was that year's most cited book, cited paper. And actually it's our PhD qualified exam must-read list. If you read our PhD reading list, her book, her paper in KDD 2014 was the must-read paper. Okay, you probably can see this one. You can see clearly on top of the mountain. There's a cable car really on to the very top of these. This one is not really climbable. Okay, it's quite dangerous. But on the top, there are lots of things. If you see, there's buildings. People, actually, I was on the top. I also took lots of pictures. There are lots of people there. Okay, it's amazing. You just watch this. It's so small, but actually it's quite big. Okay. Now, there are many, many variations. I probably just show you a few, but I will not give you a very detailed one because I will give you another very good one, which actually was done by another PhD student, Bo Zhao. I'm going to give you that one. But here I just show you this Guo Junqi actually was also graduate from UIC, but not in my group, not in this department. He actually was a PhD student in EC department, a Thomas Huang student. But he actually worked with IBM researcher, worked out another algorithm published in WWW 2013. Now he's a professor in University of Central Florida or International University of Florida, but whatever. He is a professor in Florida. And this is a truth finding in a way, you probably can see. He explored the fact-object hierarchy. That means he clustered the objects in a different way. You just think about it, even for bookseller, you probably can think some books, for example, this is a children's book. Sometimes they sell other books, but the children's book may be more trustable. They do better work. The other books probably do not do good work. You go to a university bookstore, they sell like a lot of university textbooks. Likely that parts of the information may be more trustable. Okay? But they sell other books, they may not do as good job. That's possible, right? So you probably can see he basically tried to group those group the facts and group the information provider in some kind of a object fact hierarchy, and then try to work it out. Okay. There's another one by Dong Wang, who also from UIC, but not my group, but in Tarek Abdelzar group, working on using expectation maximization framework, work out this one. Okay, it simply says he, take all these as a binary function using estimation theory, get into expectation maximization, and finally finding the trustability of the one. But I will not give you, if you're interested, you can read this one. But this is also very interesting because this Dong Wang also become a professor, now is a professor in Notre Dame. Okay, so they all do truth finding. They all get a professor job, but I can see. And then there are quite a few others. For example, I probably should mention one is Dan Ross in computer science and Professor Zhai in computer science. They all work out a few very good papers on truth finding. Everybody of them cite Xiaoxin's paper because that's the first one, okay, including Luna Dong in Google. They all cite his truth finder. His truth finder probably in that whole field is the most cited paper, okay? Because you can see it's very simple, but it really works. But I will not give you the detailed one because there are lots of paper. I just give you, like I said, Luna Dong. She actually did a lot of truth discovery and data integration work. Currently, she is at Google. Actually, I met her last Friday. They all did a really good work, but I just to give you lots of references you can read. This is the picture I took right on the tip of this, Sugarloaf Mountain. Because once you get that high, you can see all the surrounding mountains, and this is right at the sunset time. The sun just was blocked by the mountain. You can see the gorgeous view. Actually, if you watch down a little, that's a whole city, Rio, the city with lots of buildings, high rises. But they are all, compared to the mountain, they are all very low. Okay. Now I give you another piece of brilliant work. Was done by Bo Zhao, and I actually did not get a chance to meet him last Friday, but when he graduated, actually before his graduation, he was grabbed by Microsoft Research in the Bay Area. Until, I think 2 years ago, Microsoft, just closed their Bay Area Research Center to get everybody go. Then he actually joined LinkedIn, I think. So, but his work actually mostly was done together with Microsoft researchers. You actually can see these Benjamin and Jim Gamble are Microsoft researchers. Actually, Jim Gamble was my PhD student when I was in Canada. He was the one from Canada. When he graduated, he was grabbed by the Turing Award winner, Jim Gray, joined his group in Microsoft Research. That's the reason, he actually recruited Bo Zhao. They all work in the summer. Work out another truth finding one, the truth finding published in the VLDB 2012, called Bayesian Approach to Discovering Truth from Conflicting Source of Data for Data Integration. Okay. When Bo went to Microsoft for research, that's 2011, Microsoft people actually told him, say, our group got a truth finding, which is very, very useful for them. Why? Very interesting thing is Microsoft grab lots of small companies and merge them. They basically buy those companies. But they got these companies' data. There are so many different companies' data. They want to integrate them together. Okay? But the problem is there are many things that are conflicting. Okay? So for data integration, they also find this truth finding is most useful. Okay? Because with millions pieces of information, it's impossible to do this by human. Okay? You have to think about it, the algorithm. Okay. Then the very interesting thing Bohr actually found is this. Last time we just mentioned what Xiaoxin, the truth finding algorithm, truth finder, is very critical. Set of books, okay. If you got any single piece, including like you got 3 authors, the middle or the second author, the middle name is missing, you think it's wrong, okay. Actually, some people immediately may jump out and say this is not fair, okay, because this guy actually provided 3 authors. The book really has 3 authors, okay. The only second author, the middle name is missing. You said it's wrong. You give 0 credit to Barnes Noble. Actually, it's not really fair, right? Then, actually, Bohr actually give you a very interesting case is this, okay? Suppose you read a book like a Harry Potter. Suppose you get this is a movie. Actually, this one he uses 2. One is a book. Another one is the movie. Okay, the movie one he actually used like IMDb, Netflix, or some Hulu. There are lots of movie providers. Okay, the movie provider he actually took those cast, those actors and actresses. Okay, you think about these information provider. It's impossible they provide everyone. Some provide more names, some provide less names, some provide wrong names. Okay. So how could you make a judgment? That's similar to the authors of book, but even more, because the authors of book usually have 2 authors, 3 authors, 4 authors. The cast actually have a long list. Okay. So in that sense, you probably have to retreat and think about it. If you provide information, there are many pieces of information. If you provide a little wrong, you get no credit. Actually, this is not fair, right? If you really want to do good information providing, you have to count each piece of information individually rather than thinking they are a whole. Okay, so that means instead of thinking a book has 3 authors, they put anything minorly wrong, you give them no credit. You actually will say the book has 3 authors. You provide information correctly for 2 authors, you get 2/3 of the credit, right? You provide information for 1 author, you get 1 piece of credit. But what about this? Okay, if I'm bold enough, you give me a book, you say there are some authors in the book. I actually may not or may not know. I provided 100 authors for this book. This book may be only 3 authors. I provide 100 authors. Okay, it happens because I provide 100 authors. All the 3 authors are on my list. Okay, so do you trust me 100%? What about the other guy? The other guy said, I'm more conservative. I only know 2. I provided 2 authors. Okay, you think the other guy only get 67% credit. I provide 100 authors, I got 100 credit. Which one do you trust? You probably say, I better trust the other one, because the other one is a very honest, right? He provided 2 because he only knows 2, but he provided the information I really trust, because he just provided what he really knows. I randomly pick 100 authors. It happens I cover it, but you probably don't trust it. You probably say you know nothing about it, even provided everything is right. So he actually thought about this fact. Then he split the information into multiple things. That means the fact is not single, it's a set. And he checked every member in the set. He provided a new algorithm. The new algorithm called latent truth model. Let's look at his latent truth model. Okay. So the general philosophy is this. Okay. You have entity, you have attributes, you have information source. But now if you got, like, for example, this Harry Potter and Deathly Hallows, these movies, he provide those actors and actresses. I'm very dumb on the movies. I can watch a movie, I can never remember who is who, okay? So, but he provide this, basically saying you have to watch about if you put a threshold, okay? You put it too low, you get the wrong things in. Put it too high, you get the right things out. But whatever you do, you can, if you treat everything as a whole set, as a truth, you can never be good on any answer. Okay, you actually can see this is his argument. And his argument means once you make a claim, you have to watch every member in the claim. You make the judgment in a more refined way. Okay. Then what he actually was saying is the information source, you make claims on a set, like this set could be A and B. You may make a positive claims, you may make a negative claims. I count every piece you made, and then work out a new algorithm. And his algorithm means you have a multiple true attribute values. You count every single piece. Then how he work out? Because once you count every piece of information, you need a little more sophisticated algorithm. And the sophisticated algorithm he work out is this. He basically say he used a generative model. I'm not quite sure everybody knows generative model, but I just give you a simple, very simple introduction. This actually, if you watch Daphne Collar's probabilistic graphic model, I know currently Stanford has this course. We do not have this course on probabilistic graphic model, but it's a very important concept. Anything you learn from the AI, like a topic model from information retrieval, they actually recently all use generative model. Okay. The generative model, general philosophy is this. Okay. You can, this dark one means something you really know. Okay. That means the one you can see from the real fact. That means you may have source, you may have the objects, their claim, you actually know it. But something you may not know, but those are the hidden variables. Actually, there's underneath probabilistic model. They generate these facts. That's what you can see. Okay. And you actually can see these plate, diagram. What you see is this S means there are S such things, and there are C such things, there's F such things. Actually, this nested one means for every F, there's a C such things. Nested inside. Okay. So that means you can see the observation of the claim, but underneath there are some parameters. They generate this thing. Okay. Then what you need is just basically based on some probabilistic, model. You generate this. The major difference I probably should mention is in the past, people only model something right. They don't model something wrong. Okay, and that means you model how many times you make it right, but you make mistakes. They don't count you. They say this thing not so trustable. They don't really give you a penalty. Okay, but like the example I give is I provided 100 authors, 3 of them right. Of course, 3 of right you can count 3 of right is the positive one, is 1. But I make 97 actually wrong. So that simply says this negative, I have to be responsible, right? Since I have to be responsible, this 97 all count to my zeros. I cannot make, not make wrong claims, random claims, because everything I claim right, I got a 1. But everything I claim wrong, I got 0, it still counts, right? So in that sense, he counts both of them, 1 and 0. And he feed this one into the observation, then to the claim, then justify the source, reliability. That's what he basically got this. That means if you think of most of previous model, in principle, from the generative model view, they only model 1. They don't model 0. Now he says you have to be responsible for anything you claim wrong. Okay. And with this, he actually used this beta distribution, Bernoulli distribution, to get this generative model. Okay. But I will not get into detail if you are not deep into this generative model. Of course, you can read it. But basically, it's a few statistic formulas, to use to generate, to support what is your claim on the surface. Okay. Then with this, he basically worked out the maximum, posterior, probability using Gibbs sampling. Okay. And then he take this formula to give you the whole derivation. Okay. But I will not get into these very detailed one, but I will show you what he really can achieve. Okay. Then you probably, if you like it, you can go back to read his paper in more detail. Okay. He actually used, you probably see this is exactly the source provided by Xiaoxin. The same 1,263 books. And with that many claims, with that, and 100 papers are labeled by Xiaoxin, he still uses the same data. He just showed he can beat Xiaoxin because usually one book may have more authors. And he counts every piece. You make it right, wrong, it's more refined. Okay. But he got another one because he did a summer intern at Google. They, at Microsoft Research, they really have Bing data. The Bing data is much bigger, you can see. He got 15,000 movies from 12 sources, like the Netflix, like IMDb, like all of these things. And they have 100,000 claims, and that many movie directors, and also use 100 labor data. Okay. Then you probably can see he competing with all the previous algorithms. Actually, ChooseFinder is the one. There are many other algorithms. Quite a few were following ChooseFinder. Okay, that means they did some comparison with ChooseFinder to show it's better. But he developed two algorithms. One called LTM. This LTM means latent truth model, and LTM Inc. is incremental version of the truth finding. If you look at it, what is the incremental version? He basically say, you already got a previous model. You don't want to relearn it. You don't want to redo it. What you do is take this one incrementally. If we get new books, new movies in, I incrementally adjust it. Okay, doing this incremental one. Okay, so you probably can see one is called one-sided arrow, one is called two-sided arrow. Two-sided means you are responsible for every piece of information you made wrong. Okay, like I said, I made 97 random claims. Actually, I have to be responsible. That's two-sided arrow. Then you probably can see for book data, you probably can see this for one-sided arrow, the choose finder, actually the mistake, the precision is pretty high, but it's not that high. And one-sided arrow, this LTM make almost 100% right if you only count one-sided. But on the two-sided, you are responsible for every piece of information you made wrong. You can see the F1 is the highest among all the choose-finding methods. Okay. Actually, the simplest one is voting method. It's majority voting. Majority voting simply says, I don't care, anybody is equal. Who got the most vote? That one is truth. Okay. But there could be majority of the wrong people. They voted, you still trust them. That's not good. So you probably can see the majority voting comparing with choose finder, the choose finder is still better than the majority voting, right? But his method is superior. It's much higher than any others. Okay. Then you look at the movie data, because movie data is much bigger. Okay. Nowadays it's even bigger because everybody went to Netflix or someplace to get a movie. They don't rent it anymore. So you probably can see the movie data when he did it in 2012, the performance he got it like in the F1 value is in the 90s. Okay. All the others is 80s or even lower. Okay. Like this one is at 0.048, is definitely not trustable. But you can see this one is very high. He basically beats all the algorithms. Okay. That's the one finally also get a very high citation, and Microsoft Research immediately grabbed him and give him offer before he got a summer intern back. He already have a Microsoft Research offer in hand because they really love his algorithm. They think it's great, it's brilliant. Okay. So that's and he did a very detailed study. Like you probably see, this is the AUC curve. It means that the curve is higher. Means at the early stage you already got it very high. Okay, and another thing is you look at all the different movie providers. For sensitivity, the IMDb got the highest, but for specificity is Fandango got the highest. Okay, so it's these are the two different measures he actually gave the movie source. And also for the learning time, that means how much time we need to get the correct one. Because his LTM use the generative model, which is more expensive. Okay, then you can see the time needed actually is the highest. That means it's slow. But since he has this LTM incremental version, most time you get new data, you just merge it in. So the incremental version is really fast. If you can see, that means you really, because online you can do it overnight, but online you get new data in. He can easily get into this one. Actually, I got another student, Ming-Chi, you probably saw her algorithm, the rank class algorithm. She's in Google. And she actually told me, it's very interesting in Google, she's really doing the product. She actually showed me what she was doing. And actually, she worked out one algorithm. He told me that algorithm immediately increased their advertisement, the income that month in $20 million. Okay, so she actually got promoted to senior engineering in Google. She just joined Google, I think, just 2 or 3 years ago. And she actually told me a very interesting one on this timing. She says, you can do very sophisticated, like deep learning, like embedding. Google actually allow you to do that in the machine learning group. Okay, but for her to do the real putting the ads that people can click, the company can get income, that response time must be within 100 milliseconds. Okay, you think about it. If you got over 100 milliseconds, the people click, they have to wait, they will not click. They will not use your method. So that's why she actually told me the data mining algorithm she developed is really fast. It's really under 100 milliseconds, and give you. And the interesting thing is, she's not counting on just the number of clicks paid the company. She actually watch whether people really buy. It's not just that whether people click, and she get all the statistics on whether people really buy. Okay. Then their Google charge policy changed. That means they actually put the ads. They guarantee not only people click, they also have a higher probability they will buy the product. They will make the transaction. And if people really, really like it, they really get it onto the Google, pay higher money for their ads. That's why she told me she got like $20 million increase just on the incremental part, her algorithm get $20 million, and she got a big promotion. Okay, that give you the real thing. There's a real impact on the timing. Okay, so when you develop an algorithm, you have to watch this. That means timing is important. Okay, so this is the one. I basically give you the everything already got. Probably the other thing, I probably give you a little one next time I'll wrap this section. Thank you.